guys, welcome back. So today we are going to continue to rationalize the denominator, but in this case we're going to look at the case when we have a binomial denominator. So from our previous video we were rationalizing the denominator when we only had one term. So I'm just going to go ahead put something like 1 over square root of 7. Okay, if we only have one radical, then to rationalize the denominator, then we have to ask ourselves, what do we need to do to make the denominator a perfect square? Or what if we had like a index of 3? Okay, what would I have to multiply the denominator by to make the radicand a perfect cube? Okay, so if you have a square root, let me go ahead zoom in. Okay, so if you have a square root, pretty much you ask yourself, how many more factors of 7 do I need to get to 2? Right now we have one factor of 7, so to get to 2 we need to multiply by one more factor of 7. Okay, but it's actually square root of 7. Okay, and then you simplify it and take it from there. Well, we're overachievers, so why don't we go ahead actually simplify. Okay, product of 7 and itself will give us 49. So the square root of 7 times itself will give us square root of 49. Product of 1 and root 7 is square root of 7. And then for the moment of truth, did we really rationalize the denominator? Did we get rid of the radical in the bottom? And the answer is yes. Okay, so it looks like 1 over square root of 7. When we work our magic to rationalize the denominator, that will leave us with square root of 7 over 7. Okay, so that was our bonus problem. Now, what if the index was 3? So pretty much we want the radical to cancel out. So pretty much the index is 3. So I'm going to ask myself, how many factors do I have? Okay, just 1. How many more do I need to get to 3? Oh, 2. So let's multiply top and bottom by 2 more factors of 7. Okay, but if I say it correctly, multiply top and bottom by cube root of 7 squared. Okay, so we're pretty much multiplying top and bottom by 49. Okay, so I wasn't planning on doing these bonus problems, so this is why we don't have space. When the bonus problems are planned, then I make space for them. Okay, so when we keep our cool, 7 times 7 squared without the use of a calculator, who knows what that is? Not I. So let me go ahead have not so neat solution. So let's go ahead use exponents for repeated factors. So we're going to keep the base and add the exponents. Base is 7 and the sum of the exponent is 3. So 7 times 7 squared will give us 7 cubed. So that will give us cube root of 7 cubed. And that's all under 1 times cube root of 7 squared. While we're at it, why don't we evaluate 7 squared? Okay, the square of 7 or 7 squared is 49. So that will give us cube root of 49 over, okay, coming to our problem, index is 3, power is 3, the cube or the power of 3 and the cube root undo each other, and that will leave us with the radicand of 7. So we rationalize the denominator right there. Okay, this time around we're going to look at the case where the denominator is actually a binomial. If the denominator is a binomial, then it's not as straightforward as just asking ourselves, how many factors do we need? How many factors do we want? How many factors do we need? Okay, before we do that, let's go ahead and review something from many moons ago, something about conjugate. Okay, so the conjugate of a binomial, and someone forgot to type the rest of the notes. Okay, I guess that's I. Okay, the conjugate of a binomial of the form a plus b. Okay, what is that? So conjugates are binomial expressions that differ in a sign. Okay, so the conjugate of a plus b is, I'm going to say copy opposite, because we take the first term and then take the opposite of the second term. So the conjugate of a plus b is a minus b. So now the question is, in problem A, the directions read rationalize the denominator, and then our favorite disclaimer, assume all variables represent positive real numbers. So in problem A, we're trying to rationalize the denominator. So we're trying to make the denominator a rational number. In English, get rid of the radical. So what I'm going to ask myself, how many terms do I have? So I'm going to cross my fingers. Please let it be 1. Please let it be 1. But in this case, we do not have 1. So we're not going to use the approach that we did in round 1. If we have 2 terms, then to get rid of the radical, when we have 2 terms, whether both of the terms have a radical or only one of the terms has a radical. If we have two terms, to get rid of the radical, we're going to multiply top and bottom by the conjugate. So let's do this. Conjugate of 2 minus root 3, conjugate, copy, opposite. Okay, conjugate minus 2 root 3 is 2 plus root 3. Let's go ahead and multiply top and bottom by 2 times the square root of 3. And as always, we want to have good notation. I understand myself, but if the world looks at my paper, the only thing that's being multiplied together in the bottom is the square root of 3 and 2. So we need to wrap up our conjugate along with the original denominator. Now, when the world keeps looking at my paper for the numerator, they don't see 4 times that conjugate. They just see 4 times 2. So we're going to have to wrap up that conjugate. Okay, so we're going to focus our energy on simplifying the denominator and confirm that we indeed rationalize the denominator or got rid of the radical. So depending on how comfortable you are with the multiplication shortcuts, you can remind yourself that product of conjugates gives you difference of squares. But I don't have time for that, so I'm just going to FOIL it out. Okay, so let's do this. Product of the first terms, 2 times 2 will give us 4. Product of the outer terms, 2 times root 3 will give us 2 root 3. Product of the inner terms, negative square root of 3 times 2 is just negative square root of 3 times 2. But let's go ahead write this so it's aesthetically pleasing. So we'll put the 2 first. Product of the last term, negative times positive is negative, and the square root of 3 times the square root of 3 will give us square root of 9. Let's take our time, evaluate what we can, combine what we can, and then confirm that the denominator has been rationalized. Confirm that the radical has been gone. Okay, so we have one integer. We have two terms that have a square root of 3. When we combine them, 2 minus itself will give us 0, so they cancel out. And that will leave us with minus the square root of 9, which simplifies to 3. Last time I checked, difference of 4 and 3 is 1. So after all that hard work, the denominator is 1. Let's go ahead and bring down our problem. So in the numerator, before I distribute, that will leave us with 4 times 2 plus the square root of 3. Fraction bar all over 1. Okay, but since the denominator is 1, there's really no need to write it. Okay, so we're just going to write 4 times 2 plus the square root of 3. And then distribute. Okay, product of 4 and 2 is 8. Product of 4 and the square root of 3 is 4 square root of 3. Okay, we have rationalized the denominator. We got rid of the radical in the bottom. As it turns out, we don't even have a denominator anymore, but that's out of our control. Okay, so we're going to do a total of 3 problems. 2 problems where we rationalize the denominator, and then a fun bonus problem. Okay, so let's do this. Problem B, we got 2 terms. Since at least one of those 2 terms has a radical, we're going to have to multiply by the conjugate to get rid of the radical. So conjugate, copy, opposite. Copy, opposite. Okay, so let's go ahead and do this. Let's have our good notation. We'll wrap up the conjugates along with the original 2-term expression. So let's do this, FOIL it out, or take that multiplication shortcut. Product of the first terms, square root of x times square root of x. If we multiply the radicands, that will give us square root of x squared. Product of the outer term, square root of x times square root of y. Positive times negative is negative, and the product of the radicands, namely x and y, will give us x times y. So square root of xy. Product of the inner terms, square root of y times the square root of x will give us square root of yx. But you know what? To avoid the drama, put the variable factors in alphabetical order. So we'll put square root of xy. Product of the last terms, positive times negative is negative, and the square root of y times itself will give us a square root of y squared. So we're going to take our time, simplify the, let me put an upside down brace to let myself know that this is what I'm simplifying. Let's go ahead, take our time, simplify whatever we can, combine what we can, and then confirm that the radical is gone. Okay, square root of x squared, let me go ahead, highlight that index. Let me zoom in as much as I can. Okay, so index is 2, power is 2, the square and the square root undo each other, and that will leave us with the radicand of x. negative square root of xy plus square root of y. Negative 1 plus 1 is 0, so the radicals cancel out. Minus, same speech, okay, square root of y squared, index is 2, power is 2, the square and the square root undo each other, and that will leave us with the radicand of y. Okay, so that's a lot of work. Let me go ahead and bring down what we have. Before I distribute 2, let's go ahead write down what we have. 2 times the square root of x minus square root of y all over our simplified denominator of x minus y. So if you're not jumping for joy, it's time to get up because we are happy. Why? Because the radicals are gone in the bottom. Before I distribute the 2, I'm going to ask myself, is my fraction reduced? Well, our fraction is reduced because there's nothing to cancel out. Like x minus y, we cannot cancel it out with the x minus y. There's no x minus y to cancel it with. That's what I wanted to say. Okay, so we have confirmed that our rational expression, that our fraction is reduced. So let's go ahead, distribute the 2, and be on our merry way. 2 times the square root of x will give us 2 times the square root of x. 2 times negative square root of y will give us negative 2 square root of y. And the denominator, let's go ahead, bring it down. Cool. Alright, so I think we're good. So again, we were going to do 2 problems where we rationalize a binomial denominator, and then we're just going to do this fun problem for fun. Okay, so let's call it fun problem 2. If you have the notes, then it's typed, and if you don't, then you write with me. Okay, so the directions are slightly different. So after round 1 and round 2, I'm expecting for the directions to read rationalize the denominator, but in this case we don't have those directions. It says reduce the quotient. The reason why it doesn't say rationalize the denominator is because there's nothing to rationalize. We don't have a radical in the bottom. So let me just write this problem over. Okay, so we have 2x plus the square root of 32x squared, and that's all over 6x. So the directions read reduce the quotient. Okay, so we got a fraction and we have to reduce it. At a first glance, there's nothing to reduce because 6x, 2x, and the radical don't have any factors in common other than 1. Please don't try to cross cancel the 6x with the 32x squared. 6x is not inside a radical. Okay, so no canceling just yet. What we're going to do, we're going to take our time and simplify the square root of 32x squared. And with your permission, we're going to go ahead do that in a thinking area. Okay, so it's an area where I think. So square root of 32x squared, and you are going to simplify this however you like. With you have options. You can think of a perfect square factor, or option 2, you can write 32 as a product of prime factors. We discussed both of those techniques. With your permission, I'm going to just think of a perfect square factor. So a perfect square factor of 32 is 4 or 16. With your permission, we're going to use 16. So we're going to rewrite square root of 32 as the square root of 16 times the square root of 2, and that is being multiplied by x squared. So let's do this. Evaluate what you can and then take it from there. Square root of 16 gives us 4. The square root of 2 will stay as the square root of 2. Whenever I'm taking the radical of a variable, in this case the square root, I want to pay special attention to the index. Index is 2, power is 2, they pretty much undo each other, and that will leave us with the radicand of x. Okay, let me put a raised dot. And if you don't want to do that, remember, if we were to put this in exponential form, what this boils down to, how many times does 2, let me say that again, what this boils down to is how many times does the index of 2 go into the power of 2, and 2 goes into 2 exactly 1 time. So this is why we have 1 factor of x. Let's clean this up so it looks aesthetically pleasing. So that will leave us with 4x times the square root of 2, and let's bring that to our solution. So we have 2x plus, where am I, square root of 32x squared, which thanks to our hard work simplified to 4x times the square root of 2. 4x times the square root of 2, and that's all over 6x. Okay, so the direction said reduce this bad boy, so I guess we're supposed to reduce it. You can reduce it however you like. I highly discourage you using cross-canceling notation, because when students do, they'll tend to just cancel out the 2x and 6x and not actually reduce the fraction, which means not actually divide the numerator and denominator by the same thing. So this is how we're gonna do it. Like, okay, what can I reduce by? 2x, 4x square root of 2, and 6x all have a common factor of what? I'm gonna temporarily ignore the radical, okay? 2x, 4x, and 6x all have a common factor of what? Well, they have a common factor of 2x, so we're gonna reduce this fraction by dividing top and bottom by 2x. But let's old school reduce, okay? Meaning like no cross canceling. We want to have good notation, so let's wrap up the numerator. So let's see what we get when we reduce the fraction by 2x. 2x divided by 2x will give us 1. And if you need another thinking area, then go ahead, write it, okay? 2x divided by 2x gives us 1. Plus 4x square root of 2 divided by 2x. If you need a thinking area, ain't no shame, go ahead and write it, okay? 4x square root of 2 divided by 2x, I guess that will leave us with 2 square root of 2. Okay, plus 2 square root of 2, and that's all over 6x divided by 2x. I think that's 3. Okay, and if not, go ahead, do a thinking area and confirm that it gives us 3. Okay, we have reduced it, you know. Did we like reduce it all the way? Yeah, why not? Why? Well, we've reduced it all the way because 1, 2 square root of 2, and 3 don't have any factors in common other than 1. Okay guys, so that's my time, and we did it, so we're good. Thanks.